Okay, we're going to look at amplitude for sine and cosine waves. So amplitude describes the vertical stretch, or sometimes called compression, of a sinusoidal function. We still use an a value out front of the function. So y equals a sine x or y equals a cos x. So a will be the amplitude or the vertical stretch. So let's examine number 3. Graph each of the following on the same coordinate system for the interval negative 2 pi to 2 pi. So because there's an interval in this question, we're not going to put arrowheads at the end. We'll make sure that we go as far as negative 2 pi on the x-axis and 2 pi here on the positive x-axis. So let's fill in our scale. We're going to stick to that right now. We know that every 90 degrees or pi by 2 has been working for us well. So we're going to stick with that here. Eventually we're going to look at horizontal shifts, and you will see this could change a bit. So I'm going to fill that in there. And then I'm going to look at the y-axis. I'm going to still keep this as a unit 1, and then this is negative 1. So first we're just going to graph y equals sine theta, so just as a review. So without using the unit circle, the ways I can remember it is that I try to remember that sine theta always starts at the origin. And I have a few other little tricks that I'll use later on to remind you once we do cosine again as well. So let's take a look here at the next point. It always goes up. So sine starts here and goes up, and then we go back down through here. And an end point, and I continue. So I know the pattern. I know that I have to go through the median each time. So I have a max, median, min, median. So or even let's start from here. Median, max, median, min, median, max, etc. Okay. So one of the ways I try and remember it is like crossing a border. If this was Canada up here, you have to go through security at the border before you can go down into the United States. So I sometimes say that sine starts at security, which happens to be right here at the origin. All right, let's look at what happens when we graph y equals 2 sine theta. I'm going to label this because it says to graph them all on the same grid, so I need to label them. I'm going to just switch to a red pen here too to make this stand out a little bit more. Okay, so let's take a look here at 2 sine theta. So that would mean that I have an amplitude of 2. So I'm going to have this vertically stretched. So along the x-axis that doesn't change, but instead of this being a max at 1, now the max is at 2. That point doesn't change. The min is now at negative 2. Median doesn't change. So it's still that U shape, even though sometimes when we draw this shape, we tend to make it a little more V because it does stretch out a bit. And same thing here. You change all your mins and maxes to 2s. So we have an amplitude of 2 here. So y equals 2 sine theta. And then I also have y equals 1/2. So 1/2 would mean that I would just go to 0.5. So the median stays the same, but instead of the max being at 1, now it's at 0.5. Same thing here, 0.5. So we're going to go through the points there. Again, still endpoints simply because the question gave us a specific interval or domain to graph this in. Okay, so all of the x-intercepts stayed the same. We just changed the amplitude. So if we look at a little summary for amplitude, and you can pause this video if you want to write this down. It's already written up for us here. Amplitude affects the minimum and maximum. Those points changed. And also, if we call this amplitude when we talk about sinusoidal functions, but if you're ever asked to use the language of vertical or of transformations, we would call this a vertical stretch still by a factor of a.